Hi guys, I don't have a lot of time, so I'm going to go through this kind of quickly. This is solving systems with the matrices. Okay, first you had to find out what element was indicated. Okay, remember that you have rows that go horizontally, you have columns that go vertically. Okay. For number 1, you had to find A13. That's row 1, column 3. So that is number 8. Okay, the second one is B24. So we've got our rows. We're going to indicate our columns here. Then we're going to look for row 2, column 4. So B24 is 13. Okay, B12 is row 1, column 2, which is 6. A22 is row 2, column 1 in matrix A, which is 1. B is for B5, B31 is 2. For 6, A21 is 4. Number 7, B23 is 1, and A11 is 3. Okay. Now, we're going to write the matrix for each system. Just want to make some nice, neat square brackets there. Put in our line for equals. Remember, you have 2, in number 9, we have 2 equations. We have 2 variables and a constant, so we have our x, we have our y, and we have our constant. Okay. I think I wrote a z up there. I'm not sure why I wrote a z, but it's supposed to be the c for constant. Okay. We've got x is 3, y is 1, our constant is -4 for the first equation. Second equation, we have -2 for x, we have 4 for y, and 7 for our constant. All right. Now, for the first equation in number 10, I have 6x equals 11. So I've got 6 for the x column. I don't have a y, so that's why I put the 0. Second equation, I have a -3 for x, a 4 for y, and a 2 for our answer and our constant. Number 11, all right, we have 3 rows with 4 columns. First row, 4, -1, 2, and 10. Second row, 5, 2, -3, and 0. And the third row, 1, -3, 1, and 6. In the next section, we're going to write the equation from the matrix. Okay, so we've got 3 rows, so that means 3 equations. We have a column for x, y, z, and the constant. Okay, so our first equation comes out to be 2x plus 5y is equal to 13. There's 0 z's there, so we don't have to put anything. Then we have negative 3x plus 1 plus y, excuse me, plus 2z is 6. Then we have 4x, no y's, minus 3z is 5. Number 13, just a 2 by 3, gives us 2 equations. Number 14 is a 3 by 4, gives us 3 equations with x, y, and z as our variables. Remember, if there is not a number in the variable column, you don't put anything, but if it is in the answer column, you will put the 0. Okay? All right, next. Let this play out and then I'll explain. Okay, so we had a system that we needed to solve. I took the equation there, the 4x minus y equals 10 and negative 2x plus 5y equals 4, and I put them into my computer, in my calculator, not my computer, my calculator, into a matrix. You see that in the first picture. In the second picture, I did my double R ref. Remember, matrix, second matrix, math, B for double R reference. Okay? And then I plugged in A for the name. And then I ended up getting X was equal to 3 and Y was equal to 2. Okay, next equation, 16. Okay, got our equations in there. This is a 3 by 4, so you can't see the whole matrix at one time. So I went ahead and did 2 pictures. I did the first half, and then I went all the way to the end so that you saw the last column there. Okay. Put the matrix in and went in and changed, not changed, but I did hit enter, did the double R ref, got my answer, and I ended up with X was 1, Y was negative 4, and Z was 3. Okay. Again, doing some more graphing with the calculators. Okay, number 18 and number 20. Some of this will be regular, some of this will be advanced. You can take a look at the pictures. Again, I did the matrices in 2 pictures for both of these because they were 3 by 4s. And then you end up with your reference down at the bottom that gives us our final answer, which solves our system. So for number 18, we end up with 4, negative 1, 6. And for number 20, we end up with negative 3, 6, and 1. Now, the way I would like to see you show your work when you've done it in the calculator is that you write down the matrix that goes with the equation. Okay, so what you see in the problems, I mean in the 2 pictures, in this picture and this picture here. Okay, so write that matrix out, then do your matrix here that shows what each variable is worth. Okay, and then write out your final answer in an ordered triplet. Okay. Number 23, just it already gave you the matrix, so just plug it into your calculator, do your double R ref, and find out what you end up getting. Okay, you end up with 32 half-price tickets and 68 full-price tickets. Okay. Now, the next one, number 21, this is for the advanced students. You are selling popcorn at the movie theater. You sell a total of 250 between small, medium, and large. So your first equation, x plus y plus z, is 250. It said you sold $1,726 worth of popcorn. So that was the 2x plus the 5y plus the 10z was $1,726. And then it said you sold twice as many large containers as small containers. So z is equal to 2 times x. So large is twice the smalls. I take and move my x over to get it into the right place. So my third equation is negative 2x plus z equals 0. You see on the right where I put the system into the calculators. Okay. And then at the bottom, on the bottom left, you see where I did the double R ref and ended up with our final totals. And you can see 1 is for smalls, X is 68, mediums is 46, larges is 136. If you want to double check that, twice 68 is 136. We sold twice as many larges as smalls, so you take the smalls, multiply it by 2, that gives you the large. So that works. That answer answered part A. Then part B asked, how much did you sell in small popcorns? 68 times $2 per popcorn was a total of $136. Okay, guys, that's it for homework for tonight. I'm going to let you go, and y'all have a good night.